for Friday Call. And the guest today is Patrick Moore. So phone in on 01 580 4411 and put your questions about astronomy or anything under the sun to Patrick Moore.
Hello. Well, here I am in the studio waiting to be shot at. And I gather we have got our first caller on the line. And this should be Alex Simpson, who I gather is 13 and lives in London. Hello, Alex. Are you there?
Yes.
Right. What's your question?
What was your first astronomical discovery?
Well, I've made very few discoveries. I've found one or two things here and there on the moon. But I'll tell you about a discovery I missed, and I can only blame myself for this. Way back in the year 1966, the planet Saturn was nicely visible in the sky, and the ring system was edge on to us. And as you probably know, Saturn's got a lovely system of rings. They're very thin, and when they turn edge onto us, they practically disappear. In the same way that if you hold a postcard out at arm's length and then turn it edge onto you, you can't see it properly. It appears as a thin line of light. Well, when this happens to Saturn, the small inner moons of Saturn are very nicely displayed. And I was making a series of observations of these with a fairly big telescope. And I plotted them, and I estimated their brilliancies, and I hadn't bothered to work things out very exactly. There was no particular hurry for this. And then later on in the year, in December 1966, a French astronomer named Dollfus, whom I know very well, discovered the innermost moon of Saturn, and he called it Janus. And when my observations were checked back, I had actually seen it several times without recognizing it. So I can claim absolutely no credit whatsoever. It was a discovery I missed. And that kind of thing can happen, you know. Are you interested in this kind of thing particularly?
Well, yeah, a bit.
Well, nice to have heard you anyway. Thank you very much, Alex.
Yes, goodbye.
Now, let's go on then, shall we, to our question number 2. And this is Miss Katie Jones from Cheltenham. Hello, can you hear me?
Hello, yes.
Right, what's your question?
My question is, do you think it is likely that a young amateur with an inexpensive, low-power telescope could discover something unusual, for example, a new comet, or is he stuck with merely observing what is already well known?
Well, I'm very glad you asked that one, because it was something I wanted to deal with. And the answer is that not only can amateurs make discoveries, but they have and they do. Consider, for example, a man I know very well, have known for many years, Mr. George Alcock, who lives in Peterborough. He is, by profession, a schoolmaster, and by inclination, an amateur astronomer. And he spends his nights with a pair of high-mounted binoculars, in fact, sweeping the sky, looking for new comets and things we call novae, which are new stars, or rather faint stars which flare up to greater brilliancy. And over the years, he's now discovered 4 comets and 3 novae, which is a pretty impressive record. And there are other amateurs who do the same kind of thing, although not, of course, with such great success. And the whole point here is, though, that you can't just take a telescope or a pair of binoculars and go looking around and expect to find something. It is very much a matter of patience. And I know that George Alcock spent a great many years in memorizing the positions and the brightnesses of about 30,000 stars. So obviously he can recognize them at a glance. I remember once when he discovered one of his novae, he rang up various people whom he knew, including myself, and asked us to go and check it. And I was able to take a pair of binoculars and go out and check the discovery of this new star straight away. But I would never have recognized it if he'd not told me where it was. So the answer is that you can make discoveries with a small telescope or even a pair of binoculars, but it does need a great deal of training, time, and patience. Have you got a telescope?
Oh, well, I'm hoping to get one for Christmas. I've been persuading my parents gently. And the school is hoping, Cheltenham Bourneside School, is hoping at some point to get a telescope, but that'd be quite a good one, of course.
Well, I wish you luck. And one point I would like to make here, another point I'm glad you brought up, if you're going to get an astronomical telescope, my tip is don't get too small a one, because if you're going to get an astronomical telescope that's any real use for observing, you've got to pay quite a lot of money. I mean, you've got to pay 60 or 70 pounds. And if you're not prepared to pay that, then my advice is don't begin with a telescope, but get a good pair of binoculars, which have a lot of advantages of the small telescope and not so many of the disadvantages. Anyway, I wish you all luck. Nice to have heard you. Goodbye for now.
Goodbye.
Queen from Walton-on-Thames. What can we do for you, sir?
Good morning, Patrick Moore.
Good morning.
My problem is, why do we see always the same face of the moon? Does it mean that the moon is not rotating on its central axis, in spite of statements that it does so in some books? And what factor keeps this one face toward the Earth?
Right.
One other little bit is a little philosophical. the only way the moon could rotate on its central axis would be if the Earth were to be circling around the moon.
No. Well, let's deal briefly with the second point first, shall we?
Yes.
In fact, it's not entirely correct to say that the moon is going around the Earth or the Earth is going around the moon.
No.
Actually, what's happening is that both the Earth and the moon are moving together round their balancing point, or common centre of gravity, which we call the barycenter, in very much the same way as a pair of dumbbells will go round if you twist them by their joining bar. But, of course, the difference here is that the Earth is 81 times as massive as the moon, and therefore the barycenter is actually inside the Earth's globe.
Yes,
So,
agreed.
practically, although not technically, the moon does go round us. Now, for your first point.
Yes.
The moon does rotate on its axis, and if it didn't, we would see all parts of it.
That's
And
in
the best
relation
way
to the sun, not in relation to the moon, though.
Now, let me finish. Let's have a look at what happens if you get a friend to sit in a chair
Yes,
and
I
then
know,
walk
I've read
round the
that,
chair.
but
In
it-
that case, you will surely see the answer.
But that only gives the answer, that doesn't give the answer in relation to the Earth. Why does it stay facing the Earth?
Well, this is what I'm trying to tell you. The moon goes around the Earth in 27.3 days,
Yes.
and it also spins on its axis at the same time.
But it doesn't go round on its axis if the center is away in the Earth.
I think I can only say here, if you try the experiment I've tried you with the chair, walk round it, keeping your face to the chair, you will see that, in fact, if the moon did not spin, you would see the back of your neck as you go round the chair. And in fact,
Only if I was on the sun.
quite. Well, nice to have heard you. Thank you very much indeed.
Right.
Let's move on now, can we, to Robin Gandy from London. Hello, Robin.
Hello, Patrick.
Hello. What can we do for you?
Hello, can you tell me how it is possible to determine the distance between one galaxy and another in space?
Yes. Now, this is originally done by means of special kinds of stars, which are known as Cepheid variables. See, most stars, including the sun, luckily for us, shine very steadily for year after year, century after century. They won't always do so, of course. The sun won't last forever, neither will the other stars. But so far as we are concerned, they don't alter. Now, there are certain stars which do, and we call these variable stars. And they're exactly what their name implies. They are stars which brighten and fade. And there are some special stars called Cepheids. The name actually comes from one particular star of this kind, which is known as Delta Cephei.
Yeah.
Not very far away from the pole star, not very bright. You can see it with the naked eye. Now, these Cepheids vary quite regularly. For example, Delta Cephei itself goes up and down, and it's at its brightest every 5 1/3 days. Then it goes down to minimum, then it becomes bright again. And it goes on doing that all the time, absolutely regularly. There's another one in this constellation of Aquila, the eagle, which does the same thing, only it takes just over 7 days to do it. So these Cepheid variable stars are absolutely regular. Now, the point is that for various technical reasons, we've found out that the real luminosity of one of these variable stars depends upon its period. And the longer the period, the more luminous the star. For example, the one in the eagle I was talking about, with a period of just over 7 days, is more luminous than Delta Cephei, which only has a period of 5 1/3 days. What I'm getting at is that when you study one of these Cepheid variables and find out how long it takes to go up and down in brightness, we then know how luminous it really is in terms of the sun. Follow me so far?
Yes.
Right. Now, in these outer galaxies, there are Cepheid variables. We can study these Cepheids. We can find out how long they take to vary. We can find out how luminous they really are. And if you know how luminous a star really is, and you also know how bright it looks, then you can work out its distance. In the same way, if you're standing on the seashore and you see a light out to sea and the light appears faint, it could be a brilliant light a long way away, or it could be a dim light close at hand. And if you know whether it's a brilliant light or a dim light, you'll know how far away it is. It's the same with the stars. So with these Cepheid variables, we can find out how far away they are. As they're in the galaxies, we know how far away the galaxies are. Of course, even Cepheid variables, which are powerful stars, can't be seen over, well, tremendous distances, cosmically speaking. And then there are other less direct methods. But basically, it's like that. And, of course, the nearest bright galaxy visible from here is the one in Andromeda, which is just over 2 million light years away. Ever seen it?
Yes, I have.
Well, that's the furthest thing you can ever see with the naked eye. And so if anyone asks you, how far can you see without a telescope? The answer is 2.2 million light years. And to turn that into miles, multiply roughly by 6 million million. It's quite a way, isn't it?
Yeah. Well, not walking distance.
No, it certainly is. You won't get there in 5 minutes. Well, thank you very much indeed.
Okay, thank you, Patrick.
Right.
Right, bye-bye.
Now, can we pass on from there to Mrs. Anne Gladstone, who's from Stow-on-the-Wold. Hello, Mrs. Gladstone.
Good morning, Mr. Moore.
Good morning.
I know that your opinion is that there must be life somewhere rather than us in the whole of the universe. Now, presumably, we obviously can't get there under present methods, but do you believe there is an ultimate possibility of travelling through time, Doctor Who, Star Trek-wise, or is this just purely science fiction forever and ever?
Well, at the present moment, the whole idea of time travel is, of course, pure science fiction. On the other hand, if you go back far enough, all kinds of things which are actually happening today would have been regarded as science fiction.
This is what I feel, yes.
Well, exactly. Well, let's go back in time to, let's go back to the time of Julius Caesar.
Mm-hmm.
And if you told Julius Caesar he could sit in his capital in Rome and twist a knob and look at the screen and see what's happening in Japan, I wonder whether Julius Caesar would have believed you.
Yeah.
He would have said the Latin equivalent of, this is science fiction. Well, at the moment, the whole idea of space warps and time travel, they are pure science fiction to us. And we have no idea if or when it can ever be done. But I would hesitate to say that anything is impossible. All I will say is that by our modern knowledge and with our modern methods, it is impossible. But whether it's always going to remain so, well, I'd hate to say that. What do you think about it?
Well, I feel like you do. This is not a possibility, but, in the far distant future, perhaps this may come as others have. But you yourself, you think that you can't see any way at the moment.
Well, I can't see any way at the moment. I can't see any way at the moment, but I'd hate to say it's impossible. One thing I would bear in mind, though, after all, our sun is only one of a great many stars in the galaxy, and our galaxy is only one of a great many galaxies. And there must be other Earths with other intelligent beings living on them.
Yes.
And if they're older than we are and wiser, they'd have learnt much more about the universe and possibly mastered these secrets.
They might get to us first before we get to them.
Well, it's not out of the question. On the other hand, I'm quite sure that, that every civilization, such as ours, goes through a period when it's learnt enough, technically, to destroy itself, as we could do now, and yet hasn't got the culture and the civilization not to do it.
Yes.
We can do that now with weapons which already exist.
Yes.
And I just wonder how many other civilizations in the galaxy have got to the stage we're in now, where you can master control of the atom and have actually wiped themselves out.
Yes. What about UFOs, then? Do you...
No, I'm afraid I can't believe in flying saucers, much though I'd like to.
No, you haven't had any sort of proof that, or any unexplained to you?
No, I don't think any astronomers have. They're great fun.
No.
Anyway, thank you very much indeed.
Much.
Nice to have heard you.
Thank you. Goodbye.
Now, can we come on to Stephen Roper, who's from the Crystal Palace, and I think Stephen's 10. Hello, Stephen.
Hello.
Hello. What can he do for you?
What I'd like to know is, you see, I'm very interested in astronomy and spacecraft, and I'd like to know what sort of careers are open to me when I grow older.
Well, that's also something I was hoping that somebody was going to ask me. What about careers in astronomy? Now, let me make one thing quite clear at the moment, Stephen. If you're going to go in for astronomy or any other kind of science, as a professional and make a career out of it, not as an amateur as I do, if you're going to make a career out of it, then you've got to have a science degree. And this is a world where qualifications matter, and for any kind of science now, you must be qualified. And so the first thing you've got to do, and you've got some way to go yet, is to take your GCEs, your school certificates. You've got to get the usual string of O-levels, including English and a foreign language, and then you've got to go on and get your A-levels. And if you're going to go in for science, such as astronomy, you've got to get A-levels in at least physics, mathematics, another science subject, usually chemistry, and possibly one more as well. And then when you've got your O-levels and you've got your A-levels, you can go on to take a course at a university or college and finish up with a degree, such as Bachelor of Science. But if you're going to go in for astronomy, well, oddly enough, your degree need not necessarily start off by being in astronomy. And when people ask me about this, I always give the same answer. And I say, you've got to have a degree, you've got to start with GCEs, but if you're 100% certain you want to be an astronomer and nothing else, then by all means, go and take a degree in pure astronomy. If, on the other hand, you're only 99.99% certain you want to be an astronomer, then my advice is start off by taking a basic degree in physics, because most modern professional astronomy is really astronomical physics. And once you have that, you can tack on an astronomy qualification afterwards. And the reason I say that is that a degree in physics is a very good general one, and it'll open the door to many posts in astronomy, whereas if you have a degree in astronomy, well, it's astronomy or nothing. But the essential thing is you've got to have a degree, and you've got to start off by getting those GCEs. Are you going to have a go at it yourself?
Yes.
Well, I wish you all success, and I'm sure you'll do it all right, Stephen.
Thank you very much.
Well, I wish you all luck.
All right. Thank you.
Nice to hear you. Hello, what can we do for you?
happened to Cahutek?
What happened to Cahutek? I take it you mean the comet, not the man. Well, let's guess. Cahutek's comet really was rather a disaster from the spectacular point of view. Just to recap for a moment, in the spring of 1973, Dr. Lubos Cahutek, who's a Czechoslovak astronomer, actually works at Hamburg in Germany, he discovered a comet. Well, of course, quite a number of comets are found each year, but this one was a long way away, and it showed signs of getting very bright indeed as it came in toward the sun. And we all thought we were going to have a really nice, spectacular comet round about last Christmas. And it was even thought for a time that this comet might be visible in broad daylight. And we haven't had a comet like that for a very long time. In fact, the last daylight comet visible from England was, I think, way back in 1910, and that was a bit before my time, certainly before yours, Derek. Well, Cahutek's comet came in toward the sun. It was in the right place at the right time. But comets are unreliable things, you know. And this one just didn't get bright as we hoped it would do. It just wasn't that kind of comet, and we couldn't tell as it came in toward the sun. And around about November, we realized it wasn't going to make the display we'd hoped, and of course it didn't. It was visible with the naked eye, if you knew where to look for it. It did have a tail. It was a rather beautiful comet, and of course it was well seen by the astronauts in Skylab. And I saw it myself quite a number of times. But as a spectacle, it was disappointing. And all I can really say, Derek, is that it was the wrong kind of comet. I wonder if I ought to apologize for it. But there's nothing you can do. Have you ever seen a comet yourself?
No.
Well, the next bright naked-eye comet I can really promise you is the famous Halley's Comet. And that comes back every 76 years. It was last seen in 1910, and it's going to come back once again in the year 1986. So we can promise you a bright comet then. But, of course, all the other bright comets appear out of the blue, so to speak, without warning. We don't know when they're going to come, and we could have one at any time. And by the law of averages, we're overdue. So let's hope, shall we, that we get a bright comet soon. Well, nice to have heard you. Can we come on now to Mr. Leslie Ewan, who's in Edinburgh? Hello, Mr. Ewan.
Hello.
What can we do for you?
I want to ask, does your mother take an interest in astronomy? And if she does she use your telescopes?
Yes, the answer is yes to both. In fact, it was my mother who really started me on astronomy. Because at the age of 6, I picked up a small book called The Story of the Solar System, written by a man named G.F. Chambers, who I gather was a barrister. I never met him, and I think he was probably dead before I was born, because this little book that I picked up was actually published in 1898, although I didn't read it till I was 6, and that takes us back to, 1929. Anyway, it was my mother's book. She was interested. She did, in fact, before I was born, have a little telescope, but she and then my father then went over to East Africa for a bit, and I think it was sort of lost in the move. But she did take an interest, and she still does, and she does look through my telescopes. Because my mother is essentially someone who draws and paints things, and she's done a whole series of wonderful drawings of what life may or may not be like on other worlds. And these are actually coming out very shortly in the book. So at the age of 88, she's starting a new career. But the answer is yes, she was interested, and she still is, and she does look through my telescopes.
Thank you very much.
Thank you.
Sure.
At this stage, can I just say that this is Patrick Moore again, talking from Friday Call. And if you want to ring up and put a question, I'll give you the phone number, just in case you haven't got it. It's also age 13, and he's in London, I don't quite know where. Are you there, Timothy?
Good morning, Mr. Moore.
Good morning. What can I do for you?
There have been plenty of theories, but what exactly are black holes?
Oh, dear. Trying to answer questions about black holes in a minute and a half is a bit of a tall order, but I'll do my best, Timothy. But do bear in mind that I'm bound to oversimplify things. I can't help it in a short time. So let's begin by looking at a star. And the sun is a perfectly ordinary star, one of 100,000 million stars in our own particular star system or galaxy. And as we know, an average star is a globe of extremely hot gas, and it's radiating very fiercely. And deep inside the sun, the temperature is something like 14 million degrees centigrade, which is pretty hot. But it's not true to say that the sun is burning. It's not doing that. It's creating its energy in quite a different kind of way. Basically, the sun, like most stars of its kind, is made up very largely of hydrogen, which is the lightest of all the elements. And deep down inside the sun, there's a great deal of hydrogen. And down there, where the temperature is so high and the pressure is so colossal, very odd things are happening to the hydrogen. That hydrogen is gradually being changed into the second lightest element, the one we call helium. Now, every time a little bit of hydrogen is converted into a little bit of helium, by a rather roundabout process, the sun gives off a certain amount of energy and loses a little mass. And it's that energy which keeps the sun shining, and the mass loss is absolutely staggering. The sun is losing mass at the rate of 4 million tons every second. Although, don't worry, there's plenty left, and the sun won't alter yet a while, not for several thousands of millions of years. But, of course, there is going to come a time when the supply of hydrogen fuel is going to give out. And what happens then is that the inside of the star will shrink, the outside will blow out, and the star will turn into what we call a red giant. And there are plenty of red giants in the sky. Betelgeuse and Orion, of course, is one. And then, when nuclear power fails, the star will collapse quite suddenly on the astronomical scale and become a very small, very dense thing of the kind known as a white dwarf. And, of course, the best-known white dwarf in the sky is the faint companion of Sirius. Follow me so far?
Yeah.
Right.
Yeah.
Now, that's what's going to happen to a star like the Sun. If you have a much more massive star, then the nuclear reactions are going to get out of control, so to speak, when the star uses up all its reserves. And then the star will simply explode, and it'll blow most of its material away into space in what we call a supernova explosion. And it'll end up by being a patch of gas and a very small, super-dense neutron star known as a pulsar. And, of course, the best example of this in the sky is the famous Crab Nebula in the constellation of the Bull, Taurus, which you can see with a small telescope, although not at the moment, I'm afraid, because it's badly placed in the sky, too near the sun. But that's what happens to a more massive star. It goes up as a supernova. Now consider a more massive star still, more than 10 times as massive as the sun, say. When that starts to collapse, the gravitational pull is so tremendous that the gravitational collapse goes on and on and on, and nothing can stop it. And the star gets smaller and smaller and denser and denser. And the surface gravity goes on increasing. And you finally come to a point where the escape velocity from the star is greater than that of light. And therefore, not even light can escape from this very small, super-dense, collapsed star. And if not even light can escape, you have, in fact, an area round the star where nothing can get out. And that is a black hole. Do you follow me?
Yeah.
Well, now, let me stress that that's a very oversimplified explanation. It may not be correct, and we've no actual proof that black holes exist. They are theoretical possibilities, and there are some observational indications that we know where some of them are, but we can't be sure, and not everybody believes in them. And they're very strange things indeed, if they do exist, right outside our everyday experience. I think I've given you enough to go on.
Yeah, I think so. Thanks very much.
Thanks very much.
Right.
Well, having dealt with black holes as far as I can, I'm afraid that's very oversimplified. Can we come... And can we come now? Hello, Mark Quinn down in Egham, Surrey. Are you there, Mark?
Yes, hello.
What can we do for you?
Could you tell me why Saturn has a ring and not Earth, and what the ring is made of?
Well, I can certainly tell you what Saturn's ring is made of. Saturn, incidentally, is the loveliest thing in the sky, I think. And if you look at it with even a small telescope, you're going to see this superb ring system. It's unlike anything else we know. At the moment, unfortunately, Saturn is away from the evening sky. It does rise a bit before the sun. It'll go on rising earlier and earlier each night. And round about next winter, Saturn's going to be very well placed, very high up, and the rings are going to be nicely open. Now, there are, in fact, 3 main rings, 2 bright and 1 dusky, and they're made up of small particles all going round Saturn like tiny moons. And these particles are so small by planetary standards and so close together that from the Earth they give the false impression of a solid system of rings. So there's no doubt at all that Saturn's rings are made up of particles, possibly ices or ice-coated, are all spinning round Saturn. Now, as to how they were formed, this is another matter, and there are 2 possible theories here. To start with, the ring couldn't be solid because it's pretty close to Saturn, and any solid ring or any liquid ring going round Saturn as close as that would simply be pulled to pieces by the force of gravity, because Saturn's a big world, over 70,000 miles in diameter. It's pretty massive, and it's got a very strong pull. So no solid or liquid ring could exist there. So they're definitely particles. And it could be that Saturn once had an extra moon, in addition to the 10 it still has, and that this extra moon, for some unknown reason, wandered close in to Saturn and was simply pulled to pieces by the gravitation and spread round Saturn in the form of rings. That's one idea. And, of course, if that's so, it explains why the Earth hasn't got a ring, because the Earth didn't have a second moon like that. On the other hand, there are other astronomers who tend to think that Saturn's rings never did form part of a definite moon or satellite, but was simply material that never condensed into a main body and was just left going around Saturn at the time when the big planets were formed. You can take your pick from that. On the whole, I'm a bit doubtful whether the broken-up moon theory is right, but no one really knows, and it's going to be very difficult to find out. Have you, incidentally, seen the rings yourself?
No.
Well, if you get any kind of a telescope, a 3-inch refractor, for example, or anything bigger than that, do have a look at Saturn next winter, because it really is a lovely sight, and the rings are well placed now. And just as a matter of interest, the Pioneer 11 space probe, which is now on its way to Jupiter, and will bypass Jupiter near the end of this year, has been given a path that will swing it outwards from Jupiter and take it to an encounter with Saturn. And in 1979, this space probe, Pioneer 11, should bypass Saturn, and if its equipment is still working then we may get our first close-up pictures of the rings. And that'd be something to see, wouldn't it? Well, let's hope it works. Anyhow, that's your answer. Nice to have heard you.
Thank you.
Now, can we come on then to Graham Jarvis, age 16, Bridgewater, Somerset. Hello, Graham.
Good morning, Mr. Moore.
Good morning to you.
My question is that after the Soviet-American joint probe next year, what is next in the line for manned space flights?
Well, I think a lot now depends upon the space shuttle. You see, up the present moment, space travel is extremely expensive and very wasteful in a way, because your space probes could only be used once. And if we're going to have a space station or a base on the moon, you've got to have some kind of ferry craft which can be used over and over again. And this is the development of the space shuttle, which is really a grand combination of an aircraft and a spacecraft, I suppose you can call it. And if this works, it can go up and down and be used several times. And this, of course, will make space research not only safer, but also much more economical. And this is now being developed, and it will be tested in the foreseeable future, and I think a great deal depends upon that. So, in my view, the next great development is going to be the Space Shuttle program. Then we should have a really full-scale manned space station, and I hope that's going to be international. And only when that is done will men, I think, go back to the moon. And I wouldn't say there's a lot of chance of men going back to the moon. Certainly not for 10 years, I think, and I doubt if they'll go back down much before 1990. Because, you see, if we're going to send men to and from the moon, you've got to have provision for rescue. And this was a potential weakness of the Apollo program, although luckily it never showed up.
Yeah.
So I think myself the answer is shuttle, space station, and then go back and think about the moon. But I think you'd probably agree with me, wouldn't you, that the essential thing here is to make the entire program international and not national.
Oh, certainly, yes.
And I think this Russo-American link-up in space, which is definitely going ahead, is one of the greatest things that's happened so far. Because, after all, if men are going to work together in space, well, surely we can learn to work together on the Earth. And I think, don't you, that's particularly important just now.
Well, yes, just now with all the wars and everything going around all over the place.
Absolutely, and this could go some way to all clearing it up. Let's hope so anyway. Right, thank you very much.
Thank you very much.
Now, hello, John Roberts, down in Bracknell, Berkshire. You there, John?
Yes.
Hello.
Good morning, Patrick.
Good morning.
My question is, as the sun runs out, will man have time to adapt to getting colder?
Well, yes, he will. Only oddly enough, and I touched on this a little bit earlier on when I was talking about supernovae, the sun is not getting colder as it ages. As I have said earlier on, what's going to happen to the sun eventually is that it'll use up its supply of hydrogen fuel, the inside will shrink, the outside will blow out, the sun will go through a giant stage, and there's going to be a period when it'll shine at least 100 times as energetically as it does now. And if you have 100 sun power, then I wouldn't give much grief for the Earth. And there's not very much doubt that in the foreseeable future, 5 or 6 or 7,000 million years from now, the Earth is either going to be destroyed, or else it's going to be so hot that the atmosphere will be stripped off and the seas will boil, and no life here is going to be possible. But, of course, this is a very long way ahead. The sun has existed for, well, something like 5,000 million years, probably, so it's only about halfway through its career as a bright star. And there's going to be plenty of time for mankind to have warning before the sun changes. It's so far in the future, we can't even speculate as yet, but it won't be an overnight thing. And long before then, if men still exist on the Earth and haven't wiped themselves out, then I haven't the slightest doubt they'll find a way around it. Probably by mass emigration from here to another world. But, of course, as I say, this is so far in the future that we can't even speculate at the moment. And let me stress again, there's absolutely no danger to mankind from the sun or anything else in space at the moment, and there won't be for thousands of millions of years. And the only danger to the continuance of mankind on the Earth comes from ourselves with our silly bombs. Would you agree with that, John?
Yes.
Yes, I think so, too. Anyway, the answer is man will have plenty of time to get ready, and it won't come yet a while, so don't get worried about it.
I won't.
Good.
Bye.
Bye for now. And can we call now to Mr. Basil Peters, who's down at Hounslow. He's a physicist, I gather. Hello, Mr. Peters.
Hello, Patrick Moore. The question I'd like to ask is, which theory of the creation of the universe does the major evidence support at the present time, continuous creation or the Big Bang?
Well, again, this is one where I must try and oversimplify things, I think. There are really three theories. Continuous creation, the universe has always existed and will exist forever. Cyclic, or concertina universe, where the universe goes in and out and there's a period of expansion followed by a period of contraction, so the universe is reborn every 60,000 billion years or so. Or the so-called Big Bang theory, according to which the universe was created at one set moment in time, more than 10,000 billion years ago, and is expanding now and will eventually die. Those are the three theories. In fact, the weight of evidence at the moment, and I think this is a fair statement, more or less rules out the old steady state or continuous creation theory, because it just doesn't fit the facts, and therefore we are reduced to either Big Bang or cyclic universe. But you know, I believe this is a misnomer. We hear a great deal of talk about the origin of the universe, but I'm a bit of a rebel, and I don't believe that anyone has ever discussed scientifically the origin of the universe, and I'll tell you why. See, the whole point is that you and me and this microphone into which I'm talking, and Aunt Emily and the kitchen sink and everything else, they are made up of material which exists. And that material making up you and me and Aunt Emily must have come from somewhere. So either you've got to suppose that material has always existed, or that material was suddenly created. Now, if material was suddenly created, and everything comes from that, well, what happened at an earlier period? And the answer is we don't know. If, on the other hand, material has always existed, we are going to try and believe in a period of time which had no beginning, and again, we can't do it. And in a way, you know, this is an unfair question because we lack an extra dimension. And therefore, I don't myself believe that anyone has ever discussed the origin of the universe. You've got to start with the presupposition that matter exists or is created, and no one has any idea how this happened. Once you have your material, yes, then you can work out an evolutionary sequence, beginning with, if you like, a cloud of hydrogen through space, and ending up with you and me. But you can't go back further than that. We don't know fundamentals. And the analogy I can give here is, well, just suppose the Earth is visited by a denizen of, shall we say, Alpha Centauri C, who comes across space in some unknown way, lands on the Earth, and can spend only 1 hour here before he goes home again. And he doesn't know much about the Earth, and he looks around, he sees babies, he sees boys, he sees men, he sees old men. And if he's an intelligent person, he'll be able to work out that a baby turns into a boy, and a boy turns into a man, and a man turns into an old man. But unless somebody's told him the facts of life, he won't know how a baby got there, and so he will know nothing at all about the origin of man. He'll only be able to talk about the evolution of a man. And we're in the same position with regard to the universe. So I don't think we can discuss the origin at all from a scientific point of view. Would you agree with this?
That is most interesting, your view there. I hadn't heard that put before. I'm not sure.
Well, let's think it over. Anyway, I've done my best.
Thank you very much.
Thank you for ringing up.
Thank you. Bye-bye.
And can we come now to Andrew Smith? Oh, Thaden Boys. I know that. Thaden Boys in Essex. Hello, Andrew.
Hello, Mr. Moore.
What can we do for you?
Can I ask this question, please? Some of the larger planets, such as Jupiter, have a shorter day than us. I can't understand why this is, as I would have thought they would have rotated slower than the Earth because of the larger mass and the greater gravitational pull.
Well, that's a perfectly logical idea, and superficially it looks right. But of course, as we know, in fact, the outer planets do have shorter days. Jupiter, Saturn, Uranus, and Neptune, the four giants, all go around pretty quickly. Now, one possibility here is that the revolutions of the inner planets, that's Mercury, Venus, the Earth, and Mars, have been braked by tidal effects. I mean, Mercury is a very slow spinner. It goes round once in only 58.5 of our days. And of course, it's pretty near the sun, only 36 million miles out on an average, and therefore its rotation has been braked by solar tides. And the same applies to Venus, which also is a very slow spinner indeed, and goes round the wrong way for some unknown reason. The Earth we know about, and also Mars. Tidal effects could have been called into play here. The outer planets are much further away from the sun, so these effects don't apply so much. And also, don't forget, Andrew, that even though the outer planets are so much bigger than the Earth, and you could throw 1,000 globes the volume of the Earth inside Jupiter, they are also very much less dense. For example, Jupiter is only just over 300 times as massive as the Earth, so it's not so massive as you might imagine. So the entire structure is different, and this gives rise to a quicker rotation. But I do agree that on the surface it looks odd, doesn't it? Anyhow, that's as far as we can go, I think, at the moment. Does that answer you all right?
Yes, thank you.
Good. Well, bye for now.
Thank you very much. Goodbye.
Goodbye for now. And can we come on now to York and call up Mr. Mark Jones? Hello, Mr. Jones.
Good morning to you.
Good morning to you.
I happened to be walking through the town of Richmond in Yorkshire a few weeks ago and was astonished to see on the side of the house an old AA sign, the old yellow
yes.
disc kind,
Yes.
which used, I think, to say, beware dangerous hill and this kind of thing.
Yes, I know
But
it.
this particular one said solar eclipse, June 1927.
It's June the 30th.
Center line of totality.
That's right.
And I was intrigued as to why it happened to be on a house in Richmond and why the AA should have selected this particular place to mark that. Was it unique, or did the line go right down the country, or what was the explanation?
Well, the answer is this. Let me go first, just in case anyone doesn't know how eclipses of the sun are caused, I'll just say a very brief word about those. Incidentally, Mr. Jones, I do know that stone. I saw it myself a little while ago, and I do know the answer. A total eclipse of the sun is caused when the moon goes right in front of the sun and blocks out the sun's brilliant surface for a few minutes.
Yeah.
Never as long as 8 minutes. And it's a wonderful sight, because when the sun is covered, you can see the sun's outer atmosphere, the lovely pearly corona. And it really is a superb sight, and there's nothing like it in nature. I'm lucky I've seen 4 of these eclipses,
Really?
the last one being last year. But the point is that the moon's shadow is only just long enough to touch the Earth. The end of the cone just tips us. And so as the moon passes between us and the sun, the cone of shadow sweeps over the Earth in a line, and is never more than 169 miles broad. So your total eclipse is visible over only a very narrow band across the surface of the Earth. And, of course, it usually happens that the band of totality for any particular eclipse misses inhabited countries.
Yeah.
Now, that's not entirely true. I mean, the last one went right over Africa. I saw it from the sea off the African coast. But the point is that in any particular place, a total eclipse of the sun is pretty rare. And the next one in England won't occur until 1999, August the 11th, and then you've got to go to Cornwall. Now, let's go back to June the 30th, 1927.
Yeah.
Now, there was a total eclipse then, and the line of totality went right across Yorkshire. And it went right through Richmond, and if you've been standing in the position of that stone at the right time on June the 30th, 1927, you would have seen a total eclipse of the sun. It wasn't the only place you could see it. In fact, it went right across that part of England, although, by bad luck, most of the areas at that stage were cloudy, and I think the only really good pictures of that eclipse from England were taken from Giggleswick, also in Yorkshire.
Yeah.
I mean, I was only 4 at the time. I missed it, I'm afraid. But that is the answer. If you've been standing on that stone in 1927, June the 30th, at the right time, you would have seen a total eclipse of the sun. And from nowhere in England will you see another total eclipse until 1999, and even then you've got to go to Cornwall. Does that answer you all right?
Yes, it looks as if I passed through Richmond about 47 years too late.
I'm afraid you did. Well, I say, I was down in Sussex at that stage, but it was just 2 years before I began my interest in astronomy. So I can't grumble. I have seen 4 total eclipses, and if you ever get the chance to see a total eclipse of the sun, well, do take it. I mean, there are a couple of nice ones coming up in Australia if you want to go there.
Thank you very much.
Thank you.
Thank you.
Now, can we come on to Mr. Roy Wilson, who's down at Upminster in Essex. Hello, Mr. Wilson.
Good morning, Mr. Ward.
Good morning.
I was very interested to know whether you have any idea as to any unusual soil samples that were brought back by the astronauts from the moon, which we do not know on Earth at all. And also, I'd like to know from you what, in your opinion, would be the origin of the moon itself. Was it originally part of the Earth, do you think, or do you think it came from some outside source to be captivated by our gravity?
Right. First question, these samples brought back from the moon. First of all, there are no unknown elements or no unknown substances on the moon. All the material from the moon is also known on the Earth. Because conditions on the moon are different, lower gravity, different evolution and this kind of thing, some of the actual states and conditions are different and also quite predictable, but there are no unknown substances there, and I don't think anyone really expected that there would be. Of course, the most exciting thing was the discovery of this so-called orange soil with Apollo 17. And I was actually over in Mission Control in Houston when we heard Jack Schmidt's voice coming back saying, it's orange, crazy. And we all thought, well, this might be a manifestation of late volcanic activity. But, of course, it turned out not to be that. It's very small, orange-colored, glassy beads. But still, the point is that there are no unknown substances on the moon, although some of the minerals brought back, because of the different conditions there, are in a slightly different state from those on the Earth. But there's no mystery about it. Secondly, the origin of the moon. It used to be thought that the moon broke away from the Earth a long, long time ago when the Earth was young and left the deep depression now filled by the Pacific Ocean. But this theory has been tested mathematically and it's been found to be wrong. Mathematically, it just doesn't work. Even if the moon could break away from the Earth like that, it wouldn't remain as a solid body. It would either fall back or break up. So we can now be quite certain that the moon and the Earth never formed one body. They've always been separate. And in passing, of course, analysis of the moon samples shows that the moon and the Earth are just about the same age. between 4.5 and 5,000 million years. So there are two possibilities now, I think. Either the moon used to be an independent planet going around the sun in a path of its own, and for some reason encountered the Earth and was more or less captured by us, so it stayed with us, or else the Earth and the moon were formed at about the same time in the same area of the solar system, and therefore they've always remained gravitationally linked. It's difficult to tell one from the other. Personally, my preference, and it may be a hunch only, is for number two, that the Earth and the moon have always been close together and were formed in the same way, but no one's really quite sure about it. But the one inescapable fact is that the moon and the Earth never did form one body. Does that answer you all right?
Yes, thank you very much indeed.
Thank you.
Goodbye.
Goodbye. Virgil. Let's come down to Rustington in Sussex, not very far away from where I live. Calling Andrew Myerson. Hello, Andrew.
Hello?
Hello. What can we do for you?
I'd like to ask, do you think the moon will ever be colonized by man? And if so, when?
I'm quite sure the moon will be colonized by man, and I don't guess it's very far ahead. I was talking a little while ago to Professor Werner von Braun, the great space pioneer, and the man who was really behind the launching of America's first artificial satellite. And he's firmly convinced that the moon will be colonized on quite a large scale by the year 2000. And he's been right so far. I think he's going to be right again. I would say myself that probably there are going to be full-scale lunar bases set up sometime between 1990 and 2000. And within 50 years after that, there are going to be plenty of flourishing colonies on the moon. But one thing I would stress here, you're never going to turn the moon into a second Earth because it is an unfriendly kind of world. You will never give it an atmosphere you can breathe, for example. So you've got to take all your air and your water and your supplies with you. So you can't have unlimited people on the moon. But I'm quite certain that there will be flourishing colonies there. And I'm quite certain, Andrew, that you're 13, aren't you, at the moment?
Yes.
Well, I'm quite sure then that you are going to see these colonies set up. Even at the age of 51, I may myself. But I would also say, you know, that if you're really interested and you go in for science, well, you may quite easily go to the moon yourself. Because by the time you're my age, I don't think moon travel is going to be at all a problem. So I hope you do go.
Yes.
Okay, if you do send me a postcard, won't you?
Thank you very much.
Thank
Bye-bye.
you. Bye-bye. Coming now to Mr. Bruce Goodman, who's Frinton-on-Sea, Essex. Hello, Mr. Goodman.
Hello.
What can we do for you?
Well, looking ahead to the turn of the century, what major scientific developments do you foresee?
Well, so far as astronomy is concerned, I think I've just answered that really talking to Andrew. I think the astronomy of colonies on the moon. Yeah. I would say also in other branches of science, the evolution of nuclear power, the peaceful uses of atomic energy, there are going to be very striking medical developments undoubtedly, but I wouldn't like to discuss those because I am not in any way a medical man.
No,
but I'm sure that this is going to be vital.
Do you think it may be possible that we may be able to eliminate old age in some way?
Well, I'm going to say quite frankly that you're asking me here a question which is outside my field. I'm a bit of an astronomer. I am not a medical man. I would say myself that old age is going to be a very difficult thing to combat. We can certainly make it pleasanter. Whether we can ever prolong life, I simply don't know. But really, you know, I can't give any sensible comment at all because I don't like talking about things I know nothing about. And frankly, I'm not a medical man. So now, let's wait and see.
Yes.
And can we come now to Neil Watson from Reading, who's 13? Hello, Neil.
Hello.
What about you?
Last year I looked out for the Perseid meteors in August. I failed to see more than 5 on any night. I looked between 11 and 12 o'clock. Which date this year is likely to be best for observation? And what time of the night should I look, please?
Well, the Perseid meteors is a shower we go through every year, and we are starting to go through it in the very near future. The peak time is going to be for a few days to either side of August the 12th, because that's when we go through the thick of the shower. And it should be well seen this year, simply because the moon is out of the way. And if you look up fairly high, preferably in the northeast part of the sky, and you stare up at a dark, clear sky for a few minutes, any time for the week following or the week before August the 12th, then I'll be very surprised indeed if you don't see quite a number of Perseid meteors. We certainly should do. They're a very reliable shower indeed. So let's hope we have some luck on that one, shall we? You know, that's all we're going to have time for today, which is a great pity. I've enjoyed talking to you. I hope you enjoyed listening. And so this...